grouped data. So we start our first problem. The table below shows the weights in kilograms of members in a sport club. Calculate the mean, median, and mode of the distribution. So to calculate the mean, we have our usual formula: summation of fx over summation of f. Here we need to reorganize this table in a vertical form. This table is given in a horizontal form. We have it in a vertical form. So we have the table, create another table. This is the class interval representing the masses, and we are going to have 40 to 49, 50 to 59 as it is given in the original table. Now we have our frequency to be 6, 4, 12, 14, 7, and 3. Now, from this formula, there's no room for x in this table. So we are going to generate another column for x, and that x represents the mid-value of the class intervals. So we have x, which is the mid-value of the class interval. That's going to give us, how do we get the mid-value? Is to find the average of the upper limits and the lower limit of each class interval. So we have 40 plus 49 giving us 89. 89 divided by 2 gives 44.5. And 50 plus 59 divided by 2 gives 54.5. 60 plus 69 divided by 2 gives 64.5. 70 plus 79 divided by 2 gives 74.5. 80 plus 89 divided by 2 gives 84.5. And finally, 90 plus 99 divided by 2 gives 94.5. So we now have the column for x. So we can now find our fx. That's fx means frequency times x. So, and we said the x represent the mid value of the class interval. So now we have the column fx. Fx 6 times 44.5. We have 267. 8 times 54.5 gives 436. 64.5 times 12 gives 774. 74.5 times 14 gives 1043. 7 times 84.5 gives 591.5, and finally 3 times 94.5 gives 283.5. So we can now go ahead to add the frequencies. If you sum up the frequencies, we have 50. So we have 50 there. If you sum up the frequencies, we have 50. Very simple. 14 and 6. 14 and 6 gives 20. 8 and 12 gives 20. 7 and 3 gives 10. So 20, 20, 10 will give you 50. We now add up the column for fx. That one shall be from our calculator, giving us 3,395. So we now substitute into the formula 3,395 divided by 50. So dividing it by 50, we have from our calculator, we have 67.9 as the mean of this distribution from the grouped data. So we go for the median. So for the median, the formula for group data is given. So this LM means the lower class boundary of the median class. This is the summation of the frequencies divided by 2. This is cumulative frequency of the class before the median class. The cumulative frequencies of all the class before the median class. And this is the frequency of the median class. Here, the data is arranged in ascending order. So we are going to take every parameter in this formula, solve them out, and that is the lower class boundary of the median class. First, we have to identify the median class. Since there are 50 members in the club, so the 25th and 26th members will be in the middle, since the data has been arranged in ascending order. So we add and see where 25 and 26 will be accommodated within the frequency. So we have 6 plus 8 gives 14. 14 plus 12 gives 26. So the 25th and the 26th members are here in this frequency 12. So our median class is going to be 60 to what? 69. That's going to give us the median class. So to get the lower class boundary of the median class, we look at the lower limit here and the upper limit of the class before it. Then we find the midpoint. We find the midpoint. That's 59 and 60. The midpoint is 59 plus 60 divided by 2, and that will give you 59.5. 9.5, which gives 10. And we now substitute this into the formula for mode. So LM is 69.5 into 2 over 2 plus 7, then multiply by 10. So here we have a 69.5 plus 20 over 2 plus 7 gives 9. 20 over 9. From our calculator, we have it as 71.72 as the modal class of this distribution. That brings the end of the solution to this problem on how to solve mean, median, and mode of grouped data. Please remember to subscribe to our channel at Oninab Resources, and thank you for watching this video. Bye.